Now, let's welcome our speakers tonight. First of all, we are going to have Felix Kosterhon on his keynote about vulnerability research of the Linux Audit Framework. And as part of that, he's going to share some of his insights into the research he's done about the audit framework audit, and also let us know on certain vulnerability that he discovered during the course of his research. Afterwards, we're going to have Matthias Altmann talking about malicious code injection technique we call the DOM clobbering. And as part of that, he's going to show us or showcase us how you can inject malicious JavaScript code into a website using the DOM clobbering technique. And we're going to conclude the night today with Calvin Hunch talking on the comparison of different Windows host auditing tools like Prevest, Windows Enum, and so on. And also is going to take us for a little test drive for these tools. Really looking forward for that one as well. Also keep in mind, if you have any questions, just post them in the chat or in the Slido. Now, let's start with our keynote today. So Felix Kosterhon is going to talk about the vulnerability research of the Linux Audit Framework. As part of that, Felix will share some of his results of his research about the Linux Framework Audit, which is a powerful framework to monitor systems and user activities. Apart from that, currently, Felix is working for SECUINFRA as a specialist within the SIM area, and also in vulnerability research, particularly for operating systems. Apart from his work, Felix also likes to do sports, various activities just to keep healthy, which is really important, especially during COVID time. So Felix, are you ready to present?
Yes, I'm ready. Thanks for the introduction. So, hello everybody. My name is Felix Kosterhon, and today I'm going to present to you the Linux audit system, or short Audit. I will tell you about how it works, also about its little quirks and how we can deal with them. So, let's get started. Short about myself, I was already introduced shortly. So I graduated at TU Darmstadt in IT security, and currently I'm working as cyber defense consultant at SECUINFRA in Frankfurt. And what we are doing is we protect companies from attacks using so-called SIM systems. SIM stands for Security Information and Event Management. And what we basically do is we centralize, analyze, and then correlate logs to identify attacks. So how does it look like? We have a workstation here, and we send all the logs from this workstation to a central point. So not just from one, but from many workstations. At this central point, they get collected, also often enriched with additional information. And from there, they are further forwarded to an analyzing system, to a SIM system. And when an attack happens on one of the workstations, then the analyst on the other side will know exactly what happened. And I'm also responsible for auditing in my company. And last November, we identified a CVE, which I will also present to you later. Let's start with a quick motivation. What is audit and why do we even care about it? So the Linux Audit Framework, or short Audit, it really gives us the possibility to monitor exactly what we want to see. So we can create own rules to monitor user-defined events. Probably many of you know Sysmon for Windows. And so as Sysmon provides this possibility for Windows, Audit does the same for Linux systems. And it's widely used by companies in their security operations center. So what is the role of Audit? If we think back of the schematic view from the previous slide, we have a workstation running Audit. And when an attack happens, Audit is the tool which makes sure that the attack is recognized and there is a log created on that workstation. And later, this log again is forwarded to a central point among with others and then sent to a SIM system, where the analyst can see which attack happened, what happened to the workstation. And now what happens if we cannot rely on auditing to create these logs, give us information about the attacker? Well, if it fails at this stage, the analyst has no idea what's going on and has no chance. That's why reliable logs really build the foundation for monitoring systems, such as SIM systems. And that's why we should really care about auditd. It's a very important tool to make sure to detect attacks. So first, we're going to start with a short introduction to auditd. I will present you some examples to give you a rough idea what auditd is doing. And then we will dive deeper into the topic and see how auditd behaves. Maybe we can bypass some monitoring. So yeah, let's get started. First, shortly about Linux. So it's open source. It has many distributions, and we commonly find it in server environments. And one really important thing about Linux is that there is a separation. So the operating system, where all the core functionality sits, it's located in the Linux kernel, which is separated from the user space. That means that possibly untrusted applications which are running in the user space cannot directly interact with the kernel or with the hardware. So the hardware, only the Linux kernel, the protected part of the operating system, can directly interact with the hardware. Still, for the user space applications, we need to access the core functionalities of the operating system. So to do this, we have a certain interface. It's done via so-called syscalls or system calls. And to give you a better idea, a system call, basically it's everything you're doing with files, for example. So read files, write them, open them, close them. Also, if you want to create new processes, everything is done with a system call. And if you're using one, you're telling the Linux kernel what action you want to perform, and then it's performed by the Linux kernel. We could also ask, why do we need additional logging for Linux? So the ones from you which are familiar with Linux, probably you heard of syslog. So syslog is a system which is used natively by the operating system. That means that, for example, if the operating system encounters an issue, it will log it to syslog. And why is it not sufficient for us? First, and most importantly, it only offers us information to predefined events. So we cannot influence, if we want to monitor a specific behavior, we cannot do it using syslog. And besides, the logs often provide only limited context. And later for the analyst, context is really the crucial thing. If an analyst wants to know if a log is benign or malicious, he really has to know the context, what's happening there. So we really do need auditd. And now let's have a closer look on it. So it was developed by Red Hat, and it's shipped with most distributions. So not only the Red Hat derivatives, but also other Linux distributions. And it already includes many events by default. So this means, for example, if a user is added, if a group is changed, for example, then you will immediately get an event with auditd, and it will already provide you more context than, for example, equivalent logs of syslog. Also, it allows user-defined monitoring, and that was exactly what we wanted to do. So we want to think what we want to monitor, and then we want to create our own rules. And the rule matching, which is a really nice thing, is performed directly in the kernel, which means that it's additionally protected. And we can either import single rules or also multiple rules. With multiple rules, they are grouped in so-called audit log policies. And the rule order is very important. It's first match only. So after the first rule is matched, auditd won't check for other rules. And I will visualize this for you here. So on the left side, we have the kernel part of auditd where the rule matching is performed. And now, if an event enters it, then the first rule will be checked if it matches or not. If not, the second rule, and so on and so forth. If a rule matches, we have two possibilities. Either a log is created, that would be the action always, or we don't want to have a log. And in this case, let's assume we want a log. So the kernel part of auditd, where the rule matching is performed, sends now the log to the user space component and writes it to Bob's log storage. Now, let's have a look on what rules we have. So there are three types of auditd rules. The first one is control rules. So it's basically just configuration. For example, you could delete a rule or delete all rules to get in a consistent state. And then we have two possibilities to really monitor something. So first, file watches. We can monitor certain files. And second, we can even specify which syscalls we want to monitor. So maybe at this point, I will now present you two examples to give you a rough idea. If I'm going too fast, or if you have really a question to say I cannot really have to understand it to further follow the presentation, feel free to write it to the chat. I will also have a look on it. So with the syscalls, it's, I think, a really nice possibility because, for example, in Windows, you get the information a user was created or a user was deleted, but you really don't know what's going on behind the scenes. For Linux, or especially the Syscall monitoring, things are a bit different because you know exactly what Syscall was called in the background and you know what you're actually monitoring. So file watches, they offer you the possibility to monitor either files, so non-recursive, or directories in a recursive manner. And here you can see a short example. So -v adds a file watch. In this case, we want to monitor the etc shadow file, which, for example, contains the password hashes, so encrypted or hashed passwords of the users. And then we can watch certain permissions. So we can either monitor if somebody's writing to it as read access, execution, or also if file attributes are modified. In that case, we want to get notified if either the shadow file is written to or if the file attributes change. For example, we want to know if such a password hash is manipulated. And in the end, we can also specify a so-called key. And the only purpose here is to later identify the corresponding log quickly among all the other logs. And now let's have a look on the Syscall example. It's a bit more complex, but don't worry, we will step through it step by step. First, with -a, we append another rule, and exit always just means when the Syscall is evaluated, this is the point where we want to perform the rule matching. That means exit, and always we want to create a log. But it's not so important here. Important stuff comes now, because with Syscalls, we can really use different filters with -f to specify exactly what we want to monitor. So here we want to monitor all Syscalls, as they are not specified, which has something to do with a file located in the home directory. Also, the file should be accessed in the context of user ID 0. So EUID means effective user ID. So effective user ID 0 means that it's the effective user is root. And the effective user ID tells us in what context the command was executed. So if we use sudo to execute a command with the higher privileges, the effective user ID will be set to 0. And then we have two more attributes. We have the object user ID, which is the owner of the file. And then we have the OID, which is the logged in user. So what the rule is doing is that a user accesses the file of another user using his sudo privileges, his administrative privileges. Don't worry, we're going through it again. So if I'm, for example, log into my PC, the login user ID, OID, will be set to Felix, and it won't change anymore. Even if I switch the user afterwards, doesn't matter, the user ID will be fixed. And then I'm really curious about what is in this secret.txt. I really want to read it, but it's not located in my own home directory. It's a file of Bob in his home directory. So I can't read it by default. But as I'm also an administrator, I can use sudo to execute this command in administrative context and access the file anyways. So by using sudo, the effective user ID is set to root, to 0. And the object user ID is obviously Bob, as the file belongs to Bob. And here we see that I'm abusing my privileges, and this was exactly what we wanted to know. So as you can see here, it's the home directory, the effective user ID is 0, and most importantly, the logged in user is not the same as the user which is the owner of the file. So here we detected something really useful. So nice use case by using a Syscall rule. Okay, enough for that. It's just to give you a rough idea about how auditd works and what we can do with it. Let's shift perspective a bit. So we know auditd is widely used by companies to detect attackers. So we could also maybe ask, how can we bypass the monitoring? Well, Syscall monitoring, as I already told you, it is done in the Linux kernel. And as the Linux kernel is in a protected area, it's probably not the easiest way to go. But what about file watches? With Syscall monitoring, it's probably quite obvious. We know what is monitored in the background, so certain Syscalls. But with file watches, we don't know yet. So maybe we can do something here. And how do we start our research? So yeah, sure, there's a documentation, and I think it's also always a good idea to have a look on it, but it's probably not the best primary source to get more knowledge, because you probably won't find anything about what does not work or how to bypass something here. And also, even though the source code is public available, only the kernel component of auditd has more than 11,000 different contributors. So it's really not an easy thing to dive into. And that's why I decided to go with an experimental approach. And we will see how this went. So I really wanted to know what are file watches actually doing? How is it implemented? And the man pages, here you find something like the read and write syscalls, they are omitted as they would overwhelm the logs. So if I want to monitor write access, in the background, the write syscall is not really monitored. Instead, the open flags are looked to see what permission was requested, which means you can open a file in read-only mode, in read-write or write-only. And depending on what mode you open them, for example, if you open them in read-only mode, a rule which only monitors write access won't trigger because it's read-only. But if you also open it in a way that you can write to the file, the rule will trigger. And now we could wonder, maybe not always to open a file are monitored. So if we think back, we had these syscalls, and one really important thing here is that there's not just one syscall per functionality. In fact, there are multiple which do the same action or similar to get to the same goal. And in our case, there are multiple open syscalls available. So there's open, open-add, and open by handle-add. And when I tried them, in fact, we found out that the open by handle at Syscall is not considered by auditd. That means even though a file is monitored, there is a rule for it, and the analyst would expect that to be monitored. We can bypass it. We can access it anyways by using this specific Syscall. That was also our first CVE. And the only restriction we have, or the only limit, the Syscall itself can only be invoked if the user has elevated privileges. So the capability you see there, you need it to use this kind of Syscall. So basically you need pseudo privileges. But first, let's see how this works. And so we will see if the video works. If not, let me just skip through it a bit. So here we have on top, we have this really, really important and secret file in temp secret. That's why we want to monitor it. And okay, it's not working, but don't worry, I will skip through it. So we want to monitor it, and that's why we wrote a rule. So in here you can see that we are monitoring read and write access to the file top secret, and also a change of file attributes. And if something of this happens, we want to get notified, and the string for the log is secret accessed. And now let's try this. So if, for example, we're using cut to open the file to read it, we see on the other side that the log was created. And sorry. And now here, as you can see highlighted in black, you can see that the key which we assigned to it was actually present in the log. And now let's use the open by handle at Syscall. So I created a proof of concept here. And if you read now the secret file, you will see we get the file content, but no log on the right side. So on the right side, we always see the log, and on the left side, we see the commands. But we cannot only read it, we can also append our own content if we want to. So for example, let's just append a string that we know everything because we read the file. So, and then check again, read it again to see if it was added to the file. And we see there, I know everything was also added here. And now again, if we use, let's say, a normal program, which uses one of the other open Syscalls, like open or open add, we will see a log again. Yeah, so here you see again, a log is created. And now we could think, okay, what can we do about it? This is not too hard. So we know that the open by handle at Syscall is used to do this. And if we monitor it by using the first rule you see here, we can catch the attacker which tries to use it to access the file. So if you're doing the same thing again, we're using the same command on the left side, avoid file watch read, and we read the secret. On the right side, we get notified in the log that somebody accessed our secret. Okay. So how do we deal with it? We monitor the usage of this kind of Syscall to prevent it to get abused. And so we have an attacker, and he wants to access our file by using the open by handle at Syscall. Still, there is a little challenge here, because the file name is not directly passed to the open by handle at Syscall. As the name already indicates a bit, a file handle is passed as argument. And a consequence of it is that the log does not contain the file name, only the inode. So the inode is the internal representation of a file in Linux. And the problem here is that the analyst won't know in this moment what file was accessed. And what we can do now is either we resolve it on the host or we place, for example, one rule on every file. But we could also maybe guess how the attacker is doing his attack, because he also probably started a file name. And one thing we could also handle, we could also monitor is the name to handle at Syscall, because this one can be used to get from the file name to the file handle. And from there, the file handle can be used to access the file with the respective Syscall. From an attacker's perspective now, we know, okay, we can bypass file watchers entirely if we have elevated privileges and if the defender is not aware of it. So this is great. And we could probably wonder, what could we achieve with user privileges? So what if we don't have sufficient privileges to conduct this type of attack or bypass? All interactions with auditee require elevated privileges. So we cannot really do anything here. We can't even read the logs or the log policy. But what about the monitored files? Let's have a short look here. And I also really hope that you will also participate now and guess what is happening. And let's see how good the guesses are. So let's here have a short example. On the left side, we have the audit log policy again. And now rule 2, so the third rule, it's watching a folder, the .ssh directory. And we want always to create a log if somebody is messing around with the folder. But what happens now if we rename the folder, for example? So what do you think? Is the directory still monitored? I opened the poll, and now you can go to slido.com using the displayed number. And yeah, you can tell what you think, if the folder is still monitored after renaming it, or if not. I will just wait a bit. For now, it looks like 50-50. Okay, still 4 think yes, 4 no. Ah, okay. Okay, so now comes the solution. So for you, okay, now it's again 50-50. Yeah, which is probably a good indicator that stuff like this maybe should be interesting or should be included in the documentation, because we have to know what's happening if a monitored file gets renamed. And so now it's 50-50, a little bit more people are for yes than no. And yes, it's still monitored, even if we rename the directory. And now we could probably ask ourselves, but if we create a new folder with the original name, it cannot be monitored anymore, because the rule number 2, it's still pointing to the renamed folder. So far, maybe you don't think it's a problem, but one really important aspect is, according to the configuration, still the directory.ssh is monitored. So as an analyst, if we don't know what happened in the past, we just see, okay, .ssh is monitored, even though maybe in fact it's not. And renamed, there was a renaming operation previously, we didn't catch it, and now it's actually not monitored. And what will happen if we delete a monitored file, or a monitored directory, not a file, sorry. Here, not only the directory is deleted, but also the associated rule. So now, if we recreate the same folder, again, it's not monitored because the rule doesn't exist anymore. Now, how do things change if you're using a file? So here, again, we have a rule and we want to watch the etc passvd. And again, we want to always create a log and we rename it. So what do you think now? Is the file still monitored or not anymore after we rename it? Again, the votes are open. Okay, here the picture. I thought it looks more clear because I think in the beginning everybody was saying no. Now there are joined some people who think it's still monitored. Okay. I think I will close the race now. So 30% says yes, it's still monitored, and 70% no. The majority was right. It's not monitored anymore. And now there is a follow-up question, as you may already imagine. What happens now if we create again the file with the original name? Is it again monitored? Okay. This part, thanks a lot for all the people who are participating in the votes. It's now it's the other way around. So 67% think it's still monitored and 32% says no. And again, the majority is right. But at this point, you already see that it's not really so easy to predict the behavior here. And also, some of you may wonder now, but everything is a file. So there is this Unix, let's say, this unique thing that everything is a file. So why should files and directories be different? I already see a question. I will get to it in the end. It's a really good question. Why is the handling of, first let's dive deeper here on this part. So why is the handling of files and directories different? Our first guess was it's recursive versus non-recursive monitoring, because we couldn't think of another reason for that. And how can we test it if this is really the issue here? The things about file watches is that auditd chooses automatically which kind of monitoring to apply. So if we are monitoring a file, auditd will monitor it in a non-recursive manner. And if you're monitoring a directory, it will say, okay, it gets monitored in a recursive fashion. But with Syscall rules, things are a bit different, because here we can explicitly say if we want to apply non-recursive or recursive monitoring. Even though it does not really make sense, that's not the point here, but we can do it. And then if we watch a directory in a non-recursive manner, we observe the same behavior if you rename or delete the monitored directory as we observed previously for files. And the other way around, again, doesn't make sense, but we can also create a syntactical correct rule to monitor a file in a recursive way. And again, we observe the same behavior as before for directories. So our guess gets confirmed. And now, I know it was probably a bit confusing what happened now, what happened depending on recursive, non-recursive monitoring. So here we have a short summary. On the left side, we have certain actions. So we see what happens if we rename it, delete, or if we recreate it. And then we can see what happens to the monitoring itself and what happens to the policy, so to the rule, to the associated rule. For non-recursive monitoring, it's really easy. So the policy, the rule, it doesn't change. If you rename it, it gets not monitored. And if you recreate it again, it's monitored. And for the recursive monitoring, things are a bit different. So if we rename it, it still is monitored, but if we recreate it with the same name, it's not monitored anymore. And if we delete it, yeah, the policy rule gets removed too. And now if we think from it from an attacker's perspective, if we have this situation, so we renamed .ssh, for example, to .ssh2, and the SSH folder is not monitored anymore, an attacker, so the configuration still says it's monitored, the analyst will think everything is okay, but in fact, the attacker can also put his own keys into the .ssh folder, so he could put his credentials there to make remote connections or to get access to a system, and the analyst won't know. And now we really have to think how to deal with it. So we know the monitoring behavior of files or directories. It depends on whether the monitoring is recursive or not. It has nothing to do directly with files and directories. And we had this problem with renaming directories. How does the analyst know if the current audit configuration really reflects the true monitoring behavior or not? And in fact, he cannot know. I mean, he cannot know if somebody before him missed a log, for example. But we can help him. We can use a non-recursive backup rule. So that means we have two rules. So the first rule in the first line, it's the usual file watch, and we're watching the directory temp test directory. We want to get notified if there are write changes or attribute changes. And as it's the usual watch, it's recursive. And then we add a second rule, which uses the path attribute, so -f path. So it's a non-recursive monitoring. And as I told you previously, it's first match only. So usually the first rule will apply. But now the cool thing here is if the test directory is renamed or it's deleted, the first rule won't apply anymore, but the second one will still apply. And the analyst will get a notification in the SIM, for example, with the log message test directory recreated, please reload policy. So he gets notified that something is not right here. He reloads the policy and everything is working again. And in the end, I want to share another insight with you. So we observed that two identical rules with different actions did not always trigger under the same conditions. So let's show it to you on an easy example. We monitored the read access to the file temp test. So we wanted to know when is somebody accessing temp test. And we created two rules. And both rules are matching all syscalls which are related to temp test and which have something to do with read access. And the difference now is in the first line you can see never, so we don't want a log, and the second one creates a log. But as we have first match only, actually the second rule, it should never apply. We should never see this log message, should not trigger in the log. But after renaming the file to test2 and back to test again, we observed that the exclusion did not work anymore. We observed it only for non-recursive monitoring, so only if you use the attribute path equals to some value. But the reasons so far, they remain unclear. We contacted Red Hat Inc. on that behalf, and we are still in touch with them. Also, we talked with them about the renaming directories of this problem to make sure that the configuration always reflect the current monitoring behavior. How can we deal with it here? So it's a bit more tricky here because we don't know yet the issue, the exact issue. So we don't really know how to fix it in auditd. But maybe some of you know auditbeat. So it provides similar functionality than auditd. It's a shipper from the Elastic framework. And it has, it has certain advantages. So first, yeah, the filtering is more reliable. So far, we are mainly working with auditd, but we haven't had any issues with auditbeat on that behalf. And we can still use our audit log policy. So the syntax is the same. We can use it with auditbeat. And auditbeat also offers extensive options for log processing and enrichment. And for example, you could also filter it by using regular expressions. But yeah, auditbeat also comes with certain drawbacks. So with auditd, one really cool thing is that you can also you write one policy and apply it to a lot of different systems and different distributions. And what you will encounter there is the Linux distributions, not all of them using the same syscalls. So the syscalls may differ. Also, maybe a watch directory on one system is not present on another system. So some rules will most probably fail. And with auditd, this is not a problem. So with auditd, I can specify that I want to continue loading the rules, even though if one rule has an error, it's not a problem, just load the other rules. But with auditbeat, it is an issue. So the policy, all rules have to be loaded correctly for the policy to work. And also, we encountered a rather strange issue here. Files or folders with spaces could not be used in rules. So we had these types here. So we really tried to escape the space here, but it didn't work. So we weren't able to write a rule which monitored a folder or file containing a space. We also put an issue on GitHub and Elastic discussions. So far, we are waiting for an answer. I think we got one thumb up. Yeah, let's hope that this will also get fixed. And still monitoring is possible in an indirect manner. So if you're watching the complete temp directory, we will also catch the temp one test case. Let's conclude the talk here. So I presented you auditd, and also I told you a lot about what's maybe not perfect. So we identified some quirks. For example, that file watches only considered open and open syscalls. And the recursive monitoring, it was not a very consistent behavior. And last but not least, so the non-recursive exclusion rules, they seem to be ignored sometimes. But I really want to emphasize here that we should not forget that auditd really gives us a lot of advantages too. So the rule matching in the kernel, it really increases tamper resistance. And also the syscall rules, I already told you this example with Windows before, we really know what we are monitoring in the background. So there is no abstraction layer in between. We really know what we're doing. And we can have a lot of filters to really really monitor very special events. Also, many useful configuration options. For example, the one I told you before, to ignore policy errors. And there's a variety of tools to work with, for example, to create reports or to search the logs. And last but not least, the built-in logs, which already ships with auditd, they provide us additional context. So even if we only use auditd without creating any user-defined rules, we still benefit from it. And in the end, my personal conclusion, the advantages really outweigh the disadvantages. With one little, let's say, yeah, with one little problem here. If you really rely on filtering, for example, to not overwhelm the SIM system or to don't hit any license issue, you could consider using auditbeat or to place the filtering of events afterwards. But in other cases, still, I would go with auditd. And at this point, I really hope that you, yeah, so since auditbeat brings its own little quirks, doesn't matter if you choose auditbeat, if you choose auditd, anyways, you will have some issues to deal with. So it's a compromise. There is no one solution for everything. And now I want to thank you for your attention, and I'm really curious about your questions. Also, if you have any questions later, feel free to write me a mail and I will answer it to you. Thank you.
Great, thank you, Felix. So there's been a lot of questions from the audience. I must say myself, you found really useful just to see, to understand how you actually go through that process of vulnerability identification, actually find an active exploit. So thank you very much also for that and sharing your insights on audit and audit frameworks. So we have got quite a few questions now. So let's just get started in consideration of time. The first question is what do you think about the Sysmon for Linux, and will this going to be a competitor for auditd?
Yeah, that's an interesting question. So I know that it was announced again. I didn't have a look into it until now, and I'm really curious about it. I think the interesting point here is, so it using the EPF, so it's using another infrastructure. And I think interesting part is if it also offers us a transparent monitoring, and also how the monitoring of Sysmon for Linux itself, if it also is able to monitor itself. So I'm curious if in the end it will replace it, or if you're just, for example, using both, and for example using auditd to monitor Linux for Sysmon, other way around, Sysmon for Linux, or the other way around. So far I didn't have a closer look on it. I think it's published soon. Is it already published? So I only see on Twitter that it was announced a while ago. But in the end, I think a preview is available. Okay, so I didn't have a look on it right now, but I think it's a promising approach because it will go from a directly other perspective. And then I really think that we could end with a hybrid solution to use the advantages of one to to combine the strength of both frameworks to achieve a reliable monitoring.
Okay, thank you. And the second question is whether the vulnerability you presented, the CV 2020-3551, has been already actively exploited in the wild by like threat actors. Are you aware of that?
No, I'm not aware of it, if it was already used. And also, so there was in the USSSEC mailing list, we also announced the CVE. Maybe if something happens there, you find more information there, but so far I'm not aware of it, that it was already used.
Okay, thank you. There's also another question from the chat on, is the monitoring targeting the path plus file name of the file, or is it the underlying inode? That's
a really good question. So it's definitely targeting the underlying inode. For example, if I'm creating a new hard link to the same file, also the new hard link will be monitored. But right now we don't know exactly how it is monitored, because we came up with some we were always trying to go with some edge scenarios. For example, we created a new hard link to the same inode, then we deleted the original name, and still the other file was monitored. So in some way, yes, definitely the inode has to be monitored. But on the other side, for example, if I'm just moving the file, the inode stays the same. If I'm just renaming the file, the inode stays the same. So I cannot answer it, but I can only say that definitely the inode is considered, but also the file name plays into it. I hope it's a good answer.
And there's also just a note from somebody that Sysmon for Linux final release announced for October 2021. Okay, thank you. Then there's another question. If logging is handled by the user mode agent, That's a juicy target for an adversary. What do you think about that?
Logging is, could you repeat the question?
If logging is handled by the user mode agent. So is that maybe something to attack?
Yes, for sure. I think. I mean, I don't know if if you have it in the kernel, then it's really more difficult to tamper around with it. So if everything is located in a user space, I think there are more ways to get into it. And also, yeah, I didn't have a look on it right now, but the Linux kernel, I think, due to its complexity, it also protects a bit how it also protects the audit kernel component from somebody who, for example, tries to fuzz it or try to reverse engineer it. I mean, it takes more effort to do it, and in the user space, yeah, it's far more easier to get to know it better. And I think also there you really have to be careful what you're doing if you don't want to open the possibility for an attacker here.
Thank you. And last question we have is on why are there so many rules? So he's referring to slide number 70. And why are there so many rules defined if we only need one rule to monitor the file?
Okay, yes. Let me just skip back to it. Okay, I think now we're here, or you can see it in both. This is slide 18, but it's the same. So here you see that the first two rules were the ones I told you about. So the first one was the file watch, the second one to monitor the open by hand, let's just call. And then the rules which follow, they are only here to make the log more readable for you. As you can see here, it's never exclude or always exclude. So you're excluding here certain message types. For example, if you're using sudo, you will always get a log when the sudo session starts. So user start, and you will get a log when the sudo session ends, so user end. And just that we only see on the right side when the logs we are interested in are created, we want to exclude all other log types which could be created at this moment. And that's why I added these additional rules. So they are just for you that you can observe the log more easily.
Okay, thank you. And there's also another last question coming in, and that is in case of file watches, it is decided automatically whether the file is monitored in a recursive or non-recursive manner. What happens if the file doesn't exist when the rule is created?
Yeah, that's also a good question. So in this case, we observe that always non-recursive monitoring is applied. That means if you, for example, monitor the .ssh folder, but it's not created yet, and it will be created afterwards, it will be watched in a non-recursive manner. Non-recursive means, for example, if you have subdirectories and they get modified or the contents change there, you won't see it anymore. So in that case, you would have to reload the policy that directories are recognized as directories and recursive monitoring applies.
Great, thank you. Thank you very much for this really good talk. And I see there's also really positive and strong feedback from the audience on the talk.
Thank you for the invitation.
Thank you. And I guess you also have probably a blog or something where you just talk about those results. Maybe you can just post them in if people want to have some more information about this.
Yeah, so we have from the company a tech talk, and I think there will also coming either there or on Twitter in the future, there will also coming some information about audit. Yeah. Anyways, if you have any questions, feel free to write to my mail.
All right. And thank you, Felix.